Hey, good morning. Today, let's talk about the adrenal washout. To understand this, let us first start with the basic pathology. The adrenal washout is used in order to determine if a lesion is an adrenal adenoma, which is benign. An adrenal adenoma comes from the cells within the adrenal glands, and the adrenal gland cells have a rich vascular supply because from its function, it must have a lush supply connecting to the systemic circulation. So an adrenal adenoma has lipid-rich cells and a rich vascular supply. Because of its lipid-rich cells, which are contained intracellularly, we can get or prove that it is an adenoma if we get a less than 10 Hounsfield units on our plain CT scan study. So once we get this less than 10 Hounsfield units, we can diagnose already and we don't need additional imaging. But there are also cases in which our lesion is more than 10 Hounsfield units, in which case we need to do the Adrenal Protocol. So Adrenal Protocol is used in the following settings. In the following setting in which it is we are considering a lipid-poor adenoma. Why lipid-poor? Because if it's already lipid-rich, then we can already establish it on the plain study. Remember that in order to make accurate measurements in the Adrenal Protocol, we should be able to cover 1/2 to 2/3 of the lesion. And this portion must not be inclusive of necrotic areas. It is because if you include a necrotic area in your measurement, which would contain a lot of dead cells and have a decrease in the number of capillaries there, which could cause an abnormal delayed washout. Okay? Another thing to remember is that there are mimics. Since the adrenal adenoma has a rich vascular supply, other metastases which may be hypervascular, such as renal cell carcinoma or hypervascular HCC, may appear similarly. Okay? So now let's move on to how we can remember the equation for the percentage washout. Okay, so let's look here first on the 3 measurements taken. We have the plain, we have the 1 minute, and the 15-minute scan. So naturally, when we have a plain scan, which is this, for example, this Hounsfield unit, at the 1 minute post-contrast study, the Hounsfield unit or or the attenuation will increase by the time it is measured in the portal venous space. In this example, from 26, it became 94. Now, after 15 minutes, if we take another measurement, we expect it to go down if it is an adrenal adenoma. We expect it to lose a lot of the contrast or to exhibit a washout, an increased washout of at least 60% or more in adrenal adenoma because of its rich vascular supply. So, how do we find out if 30 is indeed at least 60% or more of this enhancement here on the left, or the initial enhancement? So we're going to get the value of this distance or area. So we have to get 94 That's the enhance. Subtract it with, subtract 30 from it, thereby getting this value here, a value of this. So that's the numerator. Then we're going to divide it with this one. What is the value of this distance? So it's going to be 94 minus 26, and we put that in the equation. So that's 64 divided by 68 is 94. This means that our lesion on the delayed phase has lost more than 60% of the contrast that it has gained initially. And that hypervascularity is responsible for that. Therefore, if we get this one, it is suggestive of an adrenal adenoma. You may have heard of a relative percentage washout.